Hey, this is QAShahin, and today we're going to look at writing API tests using REST Assured. We're going to look at how to write unit tests or any form of backend sort of test using REST Assured. I've had a look around and I've had a look at a number of existing REST Assured test videos that are out there today, and I have to be honest, they're actually pretty good. And the ones that I saw, I did like and I enjoyed. And I think they're pretty clear on what it is that they're trying to do. But I do think they've missed something, which is that they sort of rely on existing APIs that are out there, or they try to simulate a black box like approach where they assume that an API will only return something very specifically and that we go ahead and write the test in that format. And I don't think that's a bad thing, but I don't think it's a great thing, because as someone who should be writing backend tests, they should have an understanding on how the backend actually behaves, because that leads you on to write much better, cleaner, and robust tests. So for my REST Assured tutorials, I've decided to do something a little bit different. Instead of just writing tests, we're also going to write our own API. We're actually going to write our API from the ground up, and we're going to write all the accompanying tests for them. So as part of this video series, we are going to write an API and we're going to write the test. There's a couple of benefits to doing this. The biggest one being you'll actually learn how to write your own API, and you'll learn how to write tests for those. So high level, we're going to use JDK 11 in order to write our tests. So we're going to do this whole thing in Java, and we're going to use Gradle as our build tool. And the library that we're going to use to write our API will be Spring Boot. And we're going to use REST Assured to actually write our tests. So if any of this stuff is not familiar, or you're sort of still trying to get to grips with things, don't worry about it. We're going to go through this on the ground that I'm going to assume that you've never used those technologies before. So we're basically going to go from the ground up. So hopefully by the end of this video, the aim would be that you've got a super lightweight API that's running locally on your machine with a test. So the first thing we're going to do is create a really basic project. Now I've decided to use IntelliJ IDEA. It doesn't really matter what IDE you use. There might be benefits for you to just stick to the same IDE I'm using, but by all means, you can use any IDE. Okay, so I'm going to create a Java Gradle project. The reason we're going to use Gradle is because Gradle is pretty lightweight when it comes to just helping you manage your dependencies, and it's pretty quick as well. So we're going to use Gradle, Java, and like I said, I'm going to use the version 11 of the JDK. And we're going to give this project a name, so I'm just going to call it REST Assured Java API. And that's it. So we now have a very simple Gradle project that's up and running, and IDE is just doing a couple of things, just pulling in a couple of things automatically for us, and this is great. So with this, the first thing we need to do is import in a couple of libraries. Now really quickly, as part of my newer versions of my videos, every single video that I do will have an accompanying blog post. So what that means is, instead of you having to type every single thing out, which is one of the failings of my previous videos, I will be providing a blog entry. So if you go to the description of this video, there should be a link in there that links you to the blog page for this on my blog site. And you should just be able to copy paste in all the dependencies. So the first few dependencies we need are the following. So I'm just going to copy paste them in as well. I've got them prepared on a notepad, and let's go through this really quickly. Now, as part of this video, my goal here is to actually get you up and running as quickly as I can with some clean-ish explanation. In the next video, we're going to really dig into this and go through it in as fine-grained detail as we can. So I've copied in a couple of dependencies, and I'm going to hit auto import so that Gradle just loads up these dependencies. And while Gradle's doing that, let me go through this. The first thing we need is we need to import in Spring Boot Starter WebKit. What this will do is this will help us to build our API. This is the fundamental building blocks of helping us write our API. We will then pull in a couple of test dependencies. So we're going to pull in Handcrest, which is essentially a collection of assertion libraries. The same here for JUnit. We're pulling in REST assured. So this is the thing. This is the heavy hitter that we're going to use to actually write our tests. And then we're also pulling in Spring Framework Boot, which is going to be used to give our test a little bit of helping hand. We'll go into all of this as the tutorial series progresses. And these last few that I've included are effectively dependencies that we sadly have to add in because of the dependencies of Java 11 and a few incompatibilities that aren't natively available on the fly. Now, fortunately, as far as our Gradle file goes, this is probably it. We may not need to visit this anymore. If we do, it might be just a couple of lines here and there. But for the most part, this is it. We don't really need to look at this again. Great. With that done, now let's go ahead and actually write our API. Now, like I said, we're going to keep this super lightweight because the focus here is to get it up and running. So under our main Java directory, I'm going to create a new package first of all, and I'm going to give this package the name com.thetestroom. The reason why I've decided to create things in a package, first of all, creating things in a package is a good thing. It helps you categorize things and makes things clean, but this will come into effect, the reasoning behind it, as we start to build more and more things around it. So with the package created, I'm going to right click on the package and I'm going to create a new Java class, and I'm going to call this application. Now, what is this class? What is the purpose of this class going to be? This is going to be the entry point to our API. Now, like I said, we're going to more or less fire through this video just to get something up and running really quickly. So the first thing I'm going to do is annotate this class with an annotation called Spring Boot Application. Now, what does this do? So I'm going to give you a high-level overview. This effectively tells Spring what the entry point to our application is. In other words, this is effectively saying, where is your main static void method sitting within your code? So in here, we're going to create a main method, and it looks just like any main method. It's going to be public static void main, and in here we're going to have an array of strings, and then within here we're going to type in Spring application dot run, and within this we're going to reference the same class, which is application dot class, and we're going to pass in the args. And let's do a little bit of cleanup. Great. So with this done, believe it or not, this is all you need to have a really super lightweight API running. Frankly, it won't do anything, but this is it. This is all you need. So if we go to here and try and run this application, what you will see are a series of things booting up here in the run window. And here we can see a few things. We can see that, if I just scroll a bit, we can see that we've started an application on port 8080. And that's it. You now actually have an application that's running on a local host port 8080. But really, nothing is actually happening. We don't actually have anything, in the sense that we've got a Spring application, which is an API, but there aren't any actual endpoints, i.e. there's nothing you can actually hit and get anything back. So what we're going to do now is actually create an endpoint. So to do this, we're going to right click on the package again, hit new, Java class, and we're just going to call this, for now, controller. So what's a controller? Why do we need to write a controller? When we executed this main method here by simply running here and saying run application, Spring in the background booted up. And when Spring was booting up, it was looking to see are there any endpoints. Now you might say, wait, you keep on saying endpoint. What do you mean by endpoint? What is an endpoint? An endpoint is if you were to go to a URL and you type in something like thetestroom.com/hello. That hello could be an endpoint. That hello could be hitting something somewhere and returning something. Now I know that sounds super vague, and let's get into that. So back into our controller, we're going to do a few things. The first thing we're going to do is annotate this with a REST controller annotation. So doing that now effectively tells Spring that anything in this class contains REST controllers. In other words, they contain endpoints. It's going to become a little bit clear as we type this in. So let's create a method and let's pretend this method is going to be our endpoint. So to do this, we're going to say public and let's return a string. And let's say something like this method is going to say hello. So say hello. And we're not going to pass any parameters. And all this is going to do is say something like hi QAShahin. Something super simple. And this method, we're going to annotate this method as well. And we're going to annotate this method with the annotation request mapping. And request mapping takes in a parameter of type string. And in here, we're going to type in the string /hi. So what is happening here? So over here, what we're saying is that this class is a controller. And within this controller class, we have an endpoint called /hi. And when we hit /hi, it will return a string. And the value of that string will be hi QAShahin. That's it. That's all you need. So we're going to go back to our application and we're just going to restart it. So now that the application is restart, let's go into a terminal. And within this terminal, let's curl to that endpoint. So if we curl and we use localhost and we say port 8080 /hi, and hi because this is what we've given the request mapping to, and we hit enter, we get back hi QAShahin. Now, if you've never written an endpoint before, or you don't know what an endpoint looks like, as far as it goes, on the most basic bare bones, this is an endpoint. So if you've managed to get this far and you got something printed here, it may not be hi QAShahin, it would be exactly what you wrote in, then give yourself a pat on the back because you've actually written your first endpoint. And that's as simple as it is. That's as simple as it is, writing an endpoint. Now, endpoints can be so creative and complex depending on the logic that happens inside of these request mapping methods. So now that we've got an endpoint, this is good because we don't have any more reliance on anything external anymore. We don't rely on an API whether it exists or not anymore. So now we can finally start looking at writing a test. So to write a test, let's open up the test directory under Java. And under Java, the first thing we need to do is create that same package structure. So we're going to say com.thetestroom. And inside here, we are going to create our tests. So while we do this, let's quickly review something. Inside our main directory, we have this package called com.thetestroom. And inside that, we have an application and we have a controller. So when we write our test, the test itself should mimic the exact same package of our code. So to do that, we can just simply say controller test. Now, when you write a test file, it's good practice to create a test class that has a very similar name to the class that you're actually testing, unless if you're trying to do some sort of integration or end-to-end test. So because we're focusing more on, say, end-to-end like test, we're are going to create a test class called controller test inside the same package directory. So in here, we're going to say new Java class, and we're going to call this controller test. Now, with the controller test, we're going to do a few more annotations, and this is all going to become clear in a moment. The first thing we're going to do is add in the run with annotation, and we want to run with the Spring Runner class. We're also going to add in a second annotation called Spring Boot test, and in here we are going to supply the web environment and what value we want for it, and we want the random port value. So what is happening here? So this is actually a very powerful thing. Here we're saying that when we run this test class, we want it to run with the Spring Runner class. Essentially, it's a set of configurations. And here we're saying that when this test class runs, we want to randomly assign a port to the instance of this test class. Now this is going to become much more clearer in the next video, but for the moment, just stay with me here. So we need a couple more things. We need to somehow tell our test what port our instance of this test will run. And to do that, we provide a port, and we annotate this port as well with an annotation called local server port. And we also need to somehow assign the value of this to this. And the way we're going to do it is in a before method. So I'm going to say before, and in here we're going to say public void, let's call this setup. And in here we're going to say the rest assured dot port is equal to our port. So let me explain this really quickly. When we run this class, this is actually going to do something pretty awesome. It's actually going to run an instance of our API. It's basically going to run this thing here, but it's going to run it on a random port. The reason why running on a random port is important is if by chance it runs an instance of the API on the same port, it's going to clash. It's going to clash and it's not going to run because there's something already running on that port. So far we have some test class that when we run it, it's actually going to spin up an instance of our API. Now we can actually look at writing a test. So the first thing I want to do is create the test, an empty test class. So I'm going to say public void. And what do we actually want to test? Let's just say should get a string of hi, something like that. Now we're going to actually dive in and start to use the REST library. And again, we're going to fire through this for the moment. So the first thing we need to do is actually hit that endpoint. So what was our endpoint? Our endpoint was called hi. So let's hit that endpoint. So we're going to say get, and let's just say hi, and let's import this in. So if I try and import it in, I need to import it in as a rest assured.get. And then I want to perform a then. So the then is to help us logically break up what is happening and when. So after the then, I want to hit the body. And inside the body, I'm going to pass in a matcher. So I'm going to pass in a hemcrust matcher. And I'm going to pass in, for the moment, an empty string. So let's import in this empty matcher. And it's part of the hemcrust core matchers, so that's fine. Now, if I run this test, what I expect to happen is that it should run an instance of our API on a different port. It will hit this endpoint, and then it will expect a value of an empty string to be returned. Now we know that our controller returns hi QAShahin. So this test will basically fail, but this is a good thing because this will help us see if things are working or not. So whilst our application is still running, we are going to run the test as well. So we're going to say run controller test. Great. So let's have a look at what's happened. So if we click on the test and we just scroll down, we can see that it actually ran the application. And it ran it on port 63399, basically a random port. But then it did hit the endpoint and it was expecting this because this is what we passed into the test, but it actually got back a high QAShahin. So what's happened here is that our test has actually ran an instance of our API and it's hit the API and it expected the value of that API to return an empty string, but in reality it returned this. So just to clean things up, we're going to paste in this high QAShahin from here straight into our test, and we're just going to rerun our test. And there you go, it passed. And there you have it. Congratulations. What we've done is effectively created an endpoint completely from scratch. We've created an endpoint within our API application that returns a hard-coded string. And we have written a test that hits that endpoint and just tries to run a test against it. And that's it. That's it for this video. So I know in this video I've been a little vague in areas. I didn't want to balloon this video. I think this video is approaching close to the 20-minute mark, probably much more than that by now. But for this video, I really wanted to focus on helping us to get to a state where we can manage our own endpoint, write tests against it using rest assured, and to go from there. So like I said, all of this code will be available in the blog post, where the link to that blog post can be found in the description of this site. Make sure to subscribe, make sure you share my video, and make sure you leave a comment saying if this was helpful or not, and if this is the approach that you found helpful or not. Like I said, we're going to go into a little bit more detail in the next video and do a couple more things. Many thanks for watching, and I shall see you in the next one.